Yes, sir. That is present on YouTube.
Fine, we'll start the class now. So last we were discussing about nodal analysis. So if we have a circuit like this where we have a current source between two non-reference nodes, say for example current I1 is flowing from this path, current I2 is flowing from this path, and whatever is the current source value here, 4 amperes let's say. So at this node, at node 1, and let current I3 be coming from here, and current I4 be coming from here, let this be node 2. So at node 1, if you apply the KCL, you can find that I3 plus 4 amperes is equal to I4. Fine. And at node 2, what is the value? I1 plus I2 is equal to 4 amperes. Fine. So you can apply KCL at node 1, KCL at node 2. So a current source between two non-reference nodes is not an issue. Now instead of having a current source between two non-reference nodes, if for example we had a voltage source here, let current I be coming from this side. So I1 current is flowing here, I2 current is flowing here. सेम करंट यहाँ से I1 है. So if current I is getting separated into I1 plus I2, same amount of current at node 1 and at node 2, you can see that at node 1 I1 plus I2 they are merging again, so same amount of current will flow from this path, that is I. At node 2, the currents are getting separated up, I is equal to I1 plus I2. At node 1, those two currents are again merging back together, so I1 plus I2 becomes equal to I. अब इसमें इशू क्या है, जब आप नोड 2 पे या नोड 1 पे केसीएल लगाना चाहोगे तो ये जो I2 का वैल्यू है यहाँ पे, this you cannot determine because you have no idea how to determine this value because there is no resistance in this path. अगर करंट सोर्स होता तो करंट का वैल्यू तो डायरेक्टली पता थी, but with a voltage source present between two non-reference nodes, I2 uh, I2 का जो value है, we cannot determine this. We do not have any resistance in this path, so we cannot determine the value of this resistance. So that's why I said to you yesterday also that what we do is we combine node 1 and 2, and that combination of is known as a super node. अब ये कंबाइन क्यों कर सकते हैं हम, क्योंकि ये जो करंट आई यहाँ पे स्प्लिट अप हो रही थी नोड 2 पे, करंट at node 1 same amount of current will flow back into the system, that is I. So we can actually split this and we can ignore this parallel path You can have one voltage source only, or you can have a number of resistances in parallel with that voltage source. So you can actually uh, ignore those voltage sources or those resistances that are in parallel with that voltage source by combining this super node. So ultimately it will result in this circuit. यहाँ से जो करंट आई जा रही थी, यहाँ पे मैंने एक्चुअली ये रेजिस्टेंस नहीं ली थी, आई एम इग्नोरिंग दिस रेजिस्टेंस. यहाँ से जो करंट आई आ रही थी, same amount of current I will flow into this path as well. Fine. So I was getting split up into I1 plus I2. It's combining back at node 1. I1 plus I2 becomes equal to I. So whatever amount of current I is coming from this path. Yes, yes. It is not short circuit. We are not actually short circuiting it. We are actually ignoring this voltage source. Yeah, we are ignoring this. We are हम इन nodes को combine करते हैं. Yeah, in that sense, we can say it is equal to. You are shorting those two nodes. Fine. After shorting those two nodes, it becomes a combined node, a super node, and then you can do the analysis. So now let's take an example to actually see how we can solve such equations. कल जो मैंने एग्जांपल्स की थी, हमने सब में करंट सोर्स लिया था. So with current source applying KCL is easier, but with the voltage source present between two non-reference nodes, it becomes a little. You have to actually make use of the super node concept. तो आपके पास अब यहाँ पे दो वोल्टेज सोर्सेज हैं. वन इज 10 वोल्ट, another one is an 8 ohm resistance. You have an 8 ohm resistance here, 6 ohm resistance here, you have a 2 ohm resistance here, you have a 4 ohm resistance here. This voltage source is 5 volts. So let this be node 1, this be node 2, this is our node 3. Fine. And this is our reference node that will be denoting by 0. So voltage at this node 1 is V1, voltage at node 2 is V2, voltage at node 3 is V3, and voltage at this node is V0, which is actually equal to 0 volts. So let current I1 be flowing through this path, I2 be flowing through this path, I4 be flowing through this path, I3 be flowing through this path. You have one voltage source which is connected between a reference node and a non-reference node. So there is no issue with this voltage source. You can directly use it and solve the equation. But with this voltage source, which is actually present between two non-reference nodes, we have to make use of the supernode concept here. ठीक है. So what does supernode mean? We will combine nodes 2 and 3. That means जितनी current node 2 पे जा रही है, उतनी current node 2 and node 3, they are basically the same nodes when we consider them as a super node. That means जितनी current node 2 में जा रही है, उतनी current node 3 में भी जाएगी. So if in this case the current at node 2, if you see, is what, I1 minus I2. That means same current is also present at node 3, which is I4 minus I3, or in other words we can say I1 uh, 1 minute. First redraw the diagram. So we are saying this and this node is now same. Fine. So I1 is coming from this end, I2 is going here, I4 is coming from this end, I3 is going here. Fine. या फिर हम इसको you can actually represent it here. ये एक ही पॉइंट है, I1 यहाँ से आ रहा है, I4 ऊपर से आ रहा है, I2 नीचे जा रहा है, I3 भी करंट नीचे जा रही है. So at this super node now, at the super node, if we apply the KCL, I1 plus I4 is the current that's flowing into the super node, and I2 plus I3 is the current that's coming out of the super node. So I1 plus I4 will be equal to I2 plus I3. So ये आपकी एक equation हो गई. We have to actually denote this in terms of voltage now to find out the voltage. So what is I1? I1 is the voltage current that is emerging from a potential of voltage V1. It is flowing to a potential of voltage to a potential of V2 through a resistance of 2 ohms. I4 is जो अब ऊपर वाला path है, ये वाला path, it is coming from a potential of V1 flowing into a potential of V3 through a resistance of 4 ohms. I2 is the current coming from a potential of V2 to a potential of 0 volts through a resistance of 8 ohms, plus I3 is the current coming from a potential of V3 minus 0 divided by 6 ohms. So you can rearrange these terms. V1 by 2 minus V2 by 2 minus V2 by 8 plus V1 by 4 भी है इसको, minus V3 by 4 minus V3 by 6 is equal to 0. So you get something times V1 minus something times V2 minus something times V3 is equal to 0. ठीक है, तो ये आप देख सकते हो क्या होगा यहाँ पे. तो ये आपकी एक इक्वेशन हो गई. We need to find three equations because we have three variables V1, V2 and V3. So we have actually applied the KCL at the super node, that is 2 and 3 combined. Now one, we can apply KCL at node 1 also. Uh, KCL नोड 1 पे लगाने की जरूरत नहीं है. नोड 1 पे क्या होगा मैं डायरेक्टली आपको बोल दूंगा. At node 1 we do not now have a current source here. This is node 1. यहाँ पे हमें करंट सोर्स कनेक्टेड नहीं है. We have now a voltage source. So V1 किसके बराबर होगा? V1 will simply be equal to whatever amount of voltage you are applying to this voltage source. So at node 1 you can directly say V1 is directly equal to 10 volts. That's actually the amount of voltage that you are applying across this node. ठीक है, क्योंकि V1 node 1 और नोड 0, ये जो आपके बीच में, इन दोनों के बीच में जो पोटेंशियल डिफरेंस है, दैट इज इक्वल टू 10 वोल्ट्स, दैट विल सिंपली से दैट V1 इज इक्वल टू 10 वोल्ट्स। तो ये आपकी दूसरी इक्वेशन हो गई, V1 इज इक्वल टू 10 वोल्ट्स। ये आपकी सेकेंड इक्वेशन है। So we have now V1, we have the value of V2. Now we need to find the value of V3. We need third equation. Now third equation कहाँ से आएगी? Third equation हमें फिर से सुपर नोड से आएगी। सुपर नोड पे एक और चीज हमें देखने की जरूरत है। Between node 2 and 3, what is the voltage? That is 5 volts. So we can say potential difference between node 2 and node 3 is 5 volts. That means voltage V2 minus voltage V3 is equal to 5. तो ये हमारी तीसरी इक्वेशन होगी। ठीक है, तो ये पहले एक तो सुपर नोड वाली जो इक्वेशन है वहां पे केसीएल लगाना है। उसके बाद यू हैव टू एनालाइज अदर नोड्स एज वेल। नोड 1 पे हमें डायरेक्टली मिल गया V1 इज इक्वल टू 10 वोल्ट्स, और नोड 2 और नोड 3 के बीच में हमें V2 माइनस V3 भी मिल गया, दैट इज इक्वल टू 5 वोल्ट्स। तो यूजिंग, हाँ, so V2 is potential at node 2, V3 is potential at node 3. तो इन दोनों के बीच में जो डिफरेंस है that is simply equal to 5 वोल्ट। तो V2 minus V3 is equal to 5 वोल्ट। तो ये हमारी तीनों इक्वेशंस आपके ये आपके पास तीनों इक्वेशंस हैं। ये fill in the blanks, you can fill these whatever is the coefficient values here. So you have three equations now. You can solve for these three equations to find out the values of V1, V2 and V3. ठीक है, क्लियर? नाउ लेट्स, हाँ बोलो। ठीक है, मैं दूसरा क्वेश्चन दिखाता हूँ तो इससे हो सकता है आपको समझ में आ जाए। लेट अस टेक दिस एग्जांपल। सुपर नोड्स के एग्जांपल करेंगे हम आज। So you have a 14 volt voltage source here, you have a 4 ohm resistance here, you have a 3 ohm resistance here, you have 2 ohm resistance here, you have 6 ohm resistance here। यहाँ से जो करंट है that is I, इसके अक्रॉस जो वोल्टेज है that is V। क्वेश्चन इज फाइंड I एंड V। ठीक है, तो इसमें एक्चुअली आपको नोडल एनालिसिस यूज करना है टू फाइंड I एंड V। Also this is 6 volts. So first of all we'll identify the nodes in this particular circuit. This is one node, this is second node, this is our third node। ये नोड नहीं है क्योंकि यहाँ पे कोई एलिमेंट नहीं है। This is our reference node, that is 0। Fine, so that voltage we are V1, voltage we are V2, voltage we are V3 and voltage is there V0। Fine, ये जो point है, this is not a node, this is not a node because there is no element present between this in this path। So now between node 2 and node 3 you have a node 2 and node 3 is a are non-reference nodes। जहाँ पे आप देख रहे हो कि एक voltage source available है, so that means six this these two voltage, these two nodes can be used, can be combined into one super node। So if we redraw this circuit, This is 4, this is 3, this is 2, this is 6. So virtually we are saying that this voltage source can be ignored because जितनी करंट इस नोड में जाएगी उतनी करंट नोड 3 से भी वापस आएगी. ठीक है. So say for example current I1 is flowing in this path, I2 is flowing in this path, uh, I3 is flowing through this path. इसको मैं अभी I4 लिखता हूँ, ये actually I है in the question, we'll look into that later. So this node ये एक ही नोड है, तो जितनी करंट जा रही है उतनी करंट वहां से जो मिल रही है, those currents will be equal. So by saying that these 2 points are one and the same, we are saying whatever amount of current is entering this node, that will be equal to whatever current is leaving this node. The amount of current that's entering this node is I1. The amount of current that is leaving this node is I2 plus I3 plus I4. So at super node, if we apply the KCL, you'll find I1 is equal to I2 plus I3 plus I4. Let this voltage be V1. This voltage at this point be V2. Voltage at this point be V3. और ये आपकी voltage होगी यहाँ से V0. Fine. So I1 is the current that is flowing from a potential of V1 to a potential of V2 through a resistance of 4 ohms. I2 is a current flowing from a potential of V2 to a potential of 0 volts to a resistance of 3 ohms. Thus I3 is the current flowing from a potential of V3. यहाँ से जो ये करंट जा रही है ये रेफरेंस नोड में जा रही है, that's to 0 volts through a resistance of 6 ohms. I4 is the current coming from a potential of V3 to 0 volts through a resistance of 2 ohms. So V1 by 4 minus V2 by 4 minus V2 by 3 plus minus V3 by 6 minus V3 by 2 is equal to 0, which implies V1 by 4 minus 7V2 by 12 minus 8V2 by 12 is equal to 0. ठीक है, ये आपकी एक इक्वेशन हो गई. We have found one equation by using KCL at the super node. Now at node 1, we do not need to apply any KCL, we do not need to apply any KVL. V1 पे at node 1 you can directly say V1 minus V0 is equal to 14 volts, the potential difference. Since V0 is equal to 0, so V1 is simply equal to 14.
Sir, 8 V3, sir.
Hmm?
8 to V3.
Yes.
For first equation.
Yes, I have corrected that. Similarly, between node 2 and node 3, V2 minus V3 is the voltage. Between node 2 and node 3, voltage is V2 minus V3 and that is equal to ये साइन इंपॉर्टेंट है क्योंकि अब ये साइंस चेंज हो गई है. दिस इज इक्वल टू -6. तो ये आपकी तीसरी इक्वेशन होगी. तो आपके पास अब 1, 2 and 3, you have 3 equations, you have 3 variables, so you can find out the values of V1, V2 and V3. So V1, V2 and V3 आप इन तीन इक्वेशन से निकाल सकते हो. अब आपको लेकिन एक्चुअल क्वेश्चन में V और I निकालना है. V is, if you look at the circuit diagram, V is simply equal to V2. Fine. It's actually equal to V2 minus V0. V0 क्योंकि 0 वोल्ट है, so V is equal to V2. So अगर आपको V2 मिल गया तो you can find out V. And I it is simply equal to V3 minus V0 by 2 ohms, or you can say V3 by 2 ohms. और अगर आपके पास आपने V3 भी निकाल दिया, so you can also find out the value of current I.
Hello, sir.
Yes.
Please tell me how is it happened in the circuit V2 and V3 difference of 6 volts, sir?
At node 2 the voltages say V2, at node 3 the voltages say V3. So between V2 and node 2 and node 3, what is the voltage? It is simply 6 volts.
Yes, sir.
So V2 minus V3 is equal to 6 volts. अब चूंकि ये माइनस प्लस है, ये प्लस माइनस नहीं है, so it is V2 minus V3 is equal to minus 6, or you could have written V3 minus V2 is equal to plus 6 volts.
सर मैं ये पूछना चाह रहा हूँ, जैसे कि V2 V3 के बीच में कोई रेजिस्टेंस है नहीं, तो ऐसे 6 वोल्ट का मतलब डिफरेंस कैसे आ गया इनके बीच में, V3 और V2 के बीच में वोल्टेज का?
से फॉर एग्जांपल आप बाकी सर्किट को यू फॉरगेट अबाउट रेस्ट ऑफ द सर्किट, अगर खाली ये 6 वोल्ट्स होता है यहाँ पे, ठीक है, ये V2 है, ये V3 है, ये ओपन सर्किट है, तो V3 और V2 के बीच में कितनी वोल्टेज है?
6 वोल्ट सर।
हाँ, तो V3 और V2 के बीच में अब 6 वोल्ट्स है कि नहीं है?
है सर।
तो फिर
लेकिन सर वो ये कहना चाह रहा था यार,
रेजिस्टेंस
जैसे
की
कि
जरूरत
रेजिस्टेंस।
थोड़ी है आपको वोल्टेज निकालने के लिए.
ओके ओके सर।
If a voltage
लेकिन सर
source
वो
is present, voltage will be applicable across an open circuit.
देन सर यहाँ से इसका मतलब इसका सोर्स हो रहा है सर, ये 6 वोल्ट है ना सर?
ये तो वोल्टेज सोर्स है, दिस इज द सोर्स.
ओके सर, ओके नाउ अंडरस्टैंड सर।
So you have to obtain 3 equations. If you have 3 variables, you have to obtain 3 equations. So you can look at whatever possible ways. तो एक तो KCL लगाना ही है आपको सुपर नोड पे. देन अब डिपेंडिंग आपके पास अब सर्किट में करंट सोर्स है या वोल्टेज सोर्स है. इस केस में करंट वोल्टेज सोर्स था, so V1 is directly equal to 14 volts. If there was a current source there, then you have to apply KCL at node 1 also. Let us do another problem.
Sir, one question.
Yes.
Sir, is it necessary to take reference node at ground?
Reference
There are no elements. If
reference
there are no elements upside
if there are no elements,
on the upper part of the circuit.
no element means what? No element means एक simple wire है.
Resistance, sir. Yes, sir. There are no resistance.
मतलब कुछ भी नहीं है, वोल्टेज सोर्स भी नहीं है.
Yes, sir. Yes, sir.
Is there anything present in this circuit or nothing?
No, sir. Nothing.
Nothing at all means a simple wire.
Yes, sir.
So what can I say about this simple
Can
wire?
we take it as reference node?
But what with a simple wire, what are you planning to do with only one wire?
The zero potential at wire.
If this wire is not connected to anything, if there is no voltage source, there is no resistance, there is nothing in this. There has to be something for me to say that there is a reference. There needs to be at least a voltage source present here, and I can take this as a reference here. Fine. So if this is 14 volts, then I will take the जो नीचे वाला node है उसको मैं बोलूँगा it is a reference node, upper node is my non-reference node, and V1 will simply be equal to 14 volts. There needs to be something present for me to say that, for me to take a reference. If there is nothing present, then why will I take a reference? ठीक है, ये आपका दूसरा क्वेश्चन है. अब you have a 10 ohm resistor. It's in parallel with a 2 volt माइनस प्लस ऐसे, ये 2 वोल्ट है, यहाँ से आपके पास रेजिस्टेंस 2 ohms की है, यहाँ से रेजिस्टेंस, you have a resistance of 4 ohms on this side. You have now current source here of 7 amperes. You have another current source of 2 amperes. Fine. So इस केस में मेरे पास 3 ही नोड्स है. This is one node, this is second node, and this is the reference node. Voltage at this point is 0. Let voltage at this point be V1. Voltage at this point be V2. Now we have to again say for example, not for example, यहाँ से जो current है that is equal to 2 amperes. यहाँ से जो current है that is equal to 7 amperes. Let current flowing in this path be I1. Let current flowing in this path be I2. अब एक नॉन रेफरेंस नोड के बीच में वोल्टेज सोर्स है और उस वोल्टेज सोर्स के पैरेलल में एक रेजिस्टेंस भी है. ठीक है, सो you have to take the voltage source as well as the resistance with it as a super node. So this circuit will boil down to this thing. You have a 2 ampere source here, you have 2 ohm resistance here. Your resistance as well as the voltage source you have to combine, you have to take all of that as a super node. Fine. So 2 ohms is 2 amperes is the current flowing from this path, 7 amperes is the current flowing from this path, I1 is the I1 is the current here. So this node is now a super node. That means they are actually the same node. So whatever amount of current is flowing into the super node, that will be equal to whatever amount of current is coming out of the super node. So by applying KCL, इस क्वेश्चन में अब ये डिफरेंस थी कि यहाँ पे वोल्टेज सोर्स एंड रेजिस्टेंस दे वेर इन पैरेलल. We have to combine both those two into one and take that as a super node together. So by applying KCL at super node, two amperes is the current flowing into the super node. All the other currents, that's I1, I2, and 7 amperes, they are coming out of the super node. Fine. So I1 plus I2 is equal to 2 minus 7, that is minus 5. I1 is the current coming from a potential of V1. If you look in this diagram, I1 is coming from a potential of V1 to a potential of V0 through a 2 ohm resistance. So V1 minus V0 divided by 2. V2 is I2 is the current coming from a potential of V2 to a potential of 0 volts through a resistance of 4 ohms. So V1 by 2 plus V2 by 4 is equal to minus 5. So this is one equation. और जो दूसरी इक्वेशन है आपकी वो सिंपली बिटवीन V1 बिटवीन नोड्स 1 एंड 2. V1 minus V2. What is the potential difference between node 1 and 2 from the original diagram? V1 और V2 के बीच में जो potential difference है that is equal to minus 2 volts. So V1 minus V2 is equal to minus 2. So this is your equation number 2. So you have equation 1 and 2, you have two variables, so you can find out the values of V1 and V2 from these two equations now. Fine. So is this clear also?
Yes, sir.
You have 3 ohm resistance, a voltage source, another resistance. This is 2 ohms. You have 10 amperes here, 10 ampere current source. You have 4 ohm resistance here. You have 1 ohm resistance here. You have 6 ohm resistance here. This voltage plus minus 20 volts. This voltage, this is a dependable voltage source now, whose value is 3Vx, and Vx is the voltage across this resistance. So identifying the nodes, we have node 1, we have node 2, we have node 3, we have node 4. The voltage at this point is V1, V2, V3, V4. This is V0. So if a current of I1 is flowing here, current I2 is flowing in this path, I3 is the current flowing through this branch point, I5 is the current flowing through this branch, यहाँ से I1 है, and I4 is the current flowing through this branch. अब इस क्वेश्चन में क्या है कि इस क्वेश्चन में आपके पास दो वोल्टेज सोर्सेज हैं that are present between two non-reference nodes. So you have one voltage source here that's also present between two non-reference nodes. You have another voltage source here. It is also present between two non-reference nodes. So you have actually two super nodes in this case. So once you redraw the circuit, it will look something like this. Two, 10, 4, 1. This is I4. This is I5. यहाँ से जो current है I3 है. This is 3. This is 6. Current from this path is I1. Current from this path is I2. So you can see in this case, you have one super node and you have another super node. So at both these two nodes, whatever amount of current is flowing in, that will be equal to whatever amount of current is flowing out of this node. So let this be super node 1. This is super node 2. So by applying KCL, at super node 1, the current that's flowing into this, from this path, 10 amperes of current is flowing into this node, 10. From this path, I3 is the current that's flowing into this node, fine. I2 is coming out of this node, I1 is also coming out of this node, that will be equal to I1 plus I2. 10 plus I3 is coming from a potential difference of यहाँ पे पोटेंशियल V1 है, यहाँ पे V2 है, this is V3 and this is V4. So I3 is coming from a potential of V3 to a potential of V2 through a 6 ohm resistance equal to I1 plus I2. I1 is this current, it's coming from a potential of V1, it's going to a potential of V4 to a resistance of 3 ohms ऊपर वाले पाथ में ऐसे, plus I2. I2 is the current that's coming from a potential of V1 to a potential of reference node V1 minus 0 divided by through a resistance of 2 ohms. So you have V1 by 3 plus V1 by 2 plus V2 by 6 minus V3 by 6 minus V4 by 3 equal to 10. So this is equation number 1. So we have found one equation by applying KCL at supernode 1. Similarly, now we have to apply KCL at supernode 2. So this is a common node. So current of I1 is coming from here. I1 is the only current that's flowing into this node. So I1 is equal to I4, I5 and I3. I3 plus I4 and I5. They are currents coming out of this supernode. So I1 जो voltage है that is V1 minus V4 divided by 3 equal to I3. I3 is the current coming from a potential of V3 minus V2 divided by 6 plus I4 is V4 minus 0 by 1 and V3 I5 ये वाली current है, I5 is V3 minus 0 by 4, which implies V1 by 3 plus V2 by 6 minus V3 by 6 minus V3 by 4 minus V4 by 3 minus V4 is equal to 0. This is equation number 2 for you. Fine. So you have equation 1, you have equation 2. By applying KCL at supernode 1, you have got one equation. By applying KCL at supernode 2, you have found the second equation. Now from the original circuit back, between node 1 and 2, the voltage is potential is V1 minus V2 and that's equal to 20 volts. तो ये आपकी तीसरी इक्वेशन हो गई. Between node 3 and 4, potential difference is V3 minus V4. It's equal to this was 3Vx. 3Vx. Fine. Now this can be your fourth equation, but we do not know what is the value of Vx. First, we need to know what is the value of Vx. So what is Vx here? Vx is the potential across resistance. It is actually the potential between potential across this resistance of 3 ohms. Fine. You can also say this Vx is the potential difference between node 1 and node 4. You can also write it in that terms. So Vx is nothing but V1 minus V4. So V3 minus V4 is equal to 3 V1 minus V4. So V3 minus V4 is equal to 3V1 minus 3V4, or 3V1 minus V3 minus 2V4 is equal to 0 is your fourth equation. So you have obtained four equations, you have four variables. Now you can actually solve these four equations. इसमें यहाँ पे you had one voltage source present between node 1 and 2, so it was one super node. 1 and 2 forms one super node. You had a dependable voltage source present between node 3 and 4, so this becomes another super node. So you have to apply KCL at super node 1, that's actually node 1 and 2 combined, and you have to apply KCL at super node 2, that's node 3 and 4 combined. So after applying KCL at those two nodes, you get two equations. Then finding the potential difference between these two nodes, you will find out, you will get two more equations. And one more thing, we had one unknown term Vx here. Vx is simply the potential across the 3 ohm resistance, जो ऊपर वाली resistance है यहाँ पे. You can say that Vx is also equal to potential that is applied, potential difference V1 minus potential V1 minus potential V4. That means Vx is equal to V1 minus V4. So from that you get your fourth equation. So on you should be able to solve this now. So you can solve this equation and you should be getting these values. Fine. So that completes our nodal analysis. We'll do more numericals of this of later. पहले हम कल हम mesh analysis पढ़ेंगे. उसके बाद mesh analysis and nodal analysis दोनों की numericals हम एक साथ करेंगे. ठीक है, कोई डाउट है अभी तक इसमें? You have super nodes, just simply combine those two nodes. उस नोड पे कितनी करंट आ रही है, कितनी करंट जा रही है, you have to see that at that particular point. Is this fine?
Yes, sir. Yes, sir.